and sustainable urban planning, urban cities where electric vehicles will play a major role. Very interestingly, in the last 1.5 months after we had the virus scare and COVID coming in between, uh, there is also renewed interest. There is a lot of skepticism also on electric mobility because just last few days oil has fallen extremely low. So there is a lot of school of thought saying oil is so low now, do we need electric vehicles? At the same time, when you look at a lot of countries, India, particularly for instance in Wuhan, the moment the lockdown was removed, electric vehicle sale increased like anything. And today, it was also announced that electric vehicles in India grew 20% year on year from last year, and bulk of them were two-wheelers, where the people are buying two-wheeler vehicles. My idea here in this session is to try to cover a lot of topics to give you an idea of the ecosystem. I'm not going to go down into any one topic in depth because that is something which we can do if you're interested in later on and discuss into that. Uh, my idea here is to give you a broader perspective, the ecosystem, what all is happening in India, globally, technology point of view in particular. At the same time, also give you some market insights and what's happening in various countries. E-mobility is like this picture. A lot of people have a lot of opinions. It depends on where they are seeing electric mobility from or electric vehicles from. Each one will have a different perspective from technology point of view, from business model point of view. My intention here is to get you some context for you. I'll try to cover many of these boxes to give you different pictures of how the e-mobility market looks. When we talk about electric vehicles, e-mobility is a set of electric vehicles on the road. So I'll use e-mobility and electric vehicles interchangeably. I mean the same when I talk about it. Most of the time we talk about Tesla cars because I think they caught everybody's attention over the last decade or so. So that whenever we look at electric vehicles, that's the gold standard. All of us think Tesla is the gold standard, and we always compare and try to see what can be done. However, many of the times we forget that electric vehicles did not start with Tesla. Actually, it was nearly 100 plus years back, 120 years back, where the first electric vehicles were launched in UK and in US using lead acid batteries. And they were extremely popular at that time. It's very interesting that we are talking about these vehicles coming back into fashion nearly 120 or 130 later, in a different avatar, of course, and in a different way. But it was the same topic, same challenges, what we are talking right now, were discussed in the 1900s, in the beginning of the century. So it's very interesting to see that a topic which is more than 100 years old is now back in vogue and with the same challenges. In India, when we talk about electric vehicles, I'm quite sure the picture I show you is something very popular. All of you have seen this vehicle, Reva. This was the most well-known commercial vehicle on the field. So Reva is nothing but an acronym for Revolutionary Electric Vehicle Alternative. 2001 launched. It has been on road till last year, and now these cars are not sold anymore. Uh, yeah, it's not allowed on the field because of this crash test. They couldn't, these vehicles couldn't go through. But there is a newer generation of electric cars and vehicles coming in. But what again in India, though this catches everybody's imagination in the urban cities, and we know these vehicles coming to field, what we forget is there are millions of other electric vehicles already on the road. I'm not sure whether you have seen these vehicles. These are called e-rickshaws. E-rickshaws are extremely popular for last mile connectivity in North India and in many parts of India. And they are actually 1.5 million vehicles right now on road, which are running. Most of them run on lead acid, and these vehicles don't cross 30 kilometers per hour, and that's why they are called e-rickshaws. Just to give you some terminology, e-rickshaw means they are less than 30 kilometers per hour in speed, and they don't need a license plate, they don't need homologation, they don't need approvals by anybody. E-autos, on the other hand, are the regular looking auto rickshaws which can go more than 30 kilometers per hour, and then they are homologated by different bodies and also certified to be roadworthy or not. These vehicles are not. So again, in India also we have this perception that it's a cars, but what we need to remember is there are 1.5 million of the other vehicles on the ground, which is already running and which is being used by people. So, very brief history of what happened. Though I said 100 years back we had electric vehicles, why didn't we have electric vehicles later? Uh, Up to 1935, there was a huge demand on electric vehicles. Thomas Alva Edison also worked on a lot of patents in this area. Uh, the idea here was that they had no starting problems because these are at that time most of the vehicles were steam engine based or fossil fuel was just starting off. They all had a starting problem. They had to be cranked to set the vehicle to go, but electric vehicles could start automatically. So it was very, very well accepted, less noise, less smell. And very interestingly, in India now we are talking about battery swappable vehicles, but battery swappable was extremely popular in the 1900s with these vehicles. And very interesting for me because I work in that space is that the challenges we face now has been exactly the same 100 years back, where they also had similar business models for giving batteries, energy sale. All of that was done 100 years back. But by 1930s or after 1920s, they went into a decline and literally vanished out of the market. The problem was range anxiety. Very interestingly, I will tell you that's the same problem we are grappling with now. That how long will this lead acid batteries run with one single charge? How many kilometers? And the diesel and the petrol engines which came up were outbeating these vehicles. They could go much, much longer, and electric vehicles couldn't go without a charge. Speed, they couldn't go very fast. These vehicles were around 30, 35 kilometers per hour speed, whereas the petrol and fossil fuel based vehicles started going much faster. The gas became cheaper, the oil became cheaper with a lot of fields coming up. The price went down quite drastically. But the killer of them all was the introduction of Model T because Model T came in and democratized the production of cars. They came up in larger numbers, which electric vehicles couldn't catch up with, and then they really went out of market. A very interesting picture I also found, which I haven't put it here, is Henry Ford and Edison collaborated to create an electric car, but I think Ford eventually went with Model T. That's an interesting picture. Later on, nearly for 50 years, there was not much of progress on electric vehicles, but the interest again started off with an EV rover on Moon in 1972. I think with that, there was some interest to say, let's get electric vehicles. But more importantly, what pushed focus on electric vehicles is in California and many other states, there was a focus on getting zero emission vehicles. And that started to drive focus on electric cars and to see how can we get electric cars which are less emission or zero emission. And also in the 1900s, electricity was still new. The networks were coming up, whereas now I think we are quite uh, well versed with. I mean, we have a very good smart grid around the world, so electricity is available. And oil prices interestingly went up, whereas 100 years back it was other way around. Now oil prices started to go up, and then electric vehicles become an interesting topic. Also, you should remember that it is from California that we got Tesla because it was an evolution of multiple vehicles which many OEMs built, and Tesla came out with the best or the better looking alternative for most of those vehicles. Yeah, so much about the history of last 130 years. When we look at now, in the last 5 to 10 years, when you look at mobility or from an automobile industry, there are four broad topics which catches everybody's attention. We call it case, aces, depends whom you talk to. Different people use different terminology, but broadly, what is happening in a very big ways, all the vehicles are connected. Connected is where we now come with IoT as a topic, whether you look at telecom networks, 4G, 5G, or future networks as a topic, because we would like all the vehicles to be connected. So once that happens, there is a lot more different possibilities and use cases. The second thing which happened in the market is shared. I think shared mobility caught up in the last 1 decade, and where earlier on we were only talking about personal ownership of vehicles. As a population, as a society, we are much more open for a shared mobility right now. Also, in that, not only using the vehicle, we also in India and also in the US now, we got into uh, ride sharing where the same vehicle is shared by 3 to 4 unknown people. I think that became a phenomenon in terms of how we do travel between point A to point B. So connected shared happen in a very big way. Autonomous has been a very fancy topic, though there is a lot of research, a lot of work going on. It is not yet a common, not in the mainstream. We don't yet see only autonomous vehicles, but I'm quite sure that is something what the next decade will do. But in between all of that, another interesting aspect which started off with Tesla and then with most of the other OEMs joining is that all these vehicles turned electric. So we have now all these four aspects trying to drive mobility in future. We're looking at autonomous, connected, electric, and shared. So my focus is predominantly on electric in this talk, but I cannot talk only electric because all of them are connected, and most of the electric vehicles coming in are shared. So it's all interlinked, and most of the autonomous vehicles will eventually be electric. So you can't leave any one of those topics when we talk about electric vehicles. Why electric vehicles? Why do we need to move towards it? Because most of our IC engines are in a good shape. They're also now going into Euro 6 emission standards, which is also tending to almost zero emission. Why are we moving towards it? Very clearly, three aspects is what everybody will tell you. Cleaner alternative to less pollution. This was a topic I used to talk a lot in terms of India having most polluted cities. Very interesting statistics is that in Delhi, the particle per milligram of air thing was around 675 3 months back or 2 months back. Today, in Lajpat Nagar, it is sitting at around 20. So people are able to see a huge change in pollution in Delhi thanks to the lockdown we have. And a part of it is, of course, the industrial pollution which comes. A part of it comes from automobiles on the road, and I think a lot of people are taking note of it. And even from a urban planning point of view, one of the government officials, I don't want to quote him, where they're also talking, saying the two and three wheeler should in India should become electric because it will make a significant impact. Because we always talked about it, we didn't have a proof of that, saying if I take out all the vehicles from the road, will the pollution go down? We discussed about this topic many times, but we couldn't think of what how to make it happen or how to show it. I think unfortunately the COVID situation has made sure that in every city around the globe, even in India, we can see the pollutions dropping down. Of course, like I said, it's both industrial pollution and the automobile pollution, but definitely it has made an impact. From a design of the vehicle, from the maintenance of the vehicle, there is a huge change when it comes to electric vehicles. There are 80% less moving parts compared to a regular automobile, and I think that also is an interesting aspect when you look at as an industry. The moving parts are less, the wear and tear is less, the life of the vehicle is much longer, and also the maintenance cost of keeping your vehicle on the road is much lower. So I think that's a big benefit when you look at electric vehicles. And oil is already coming down. Like I said, interestingly, today the future price of oil is negative, which means we were joking in the morning that if you want to buy oil, somebody is going to pay you money to fuel your tank. I think that's the situation we are talking in the US. But overall, even in the Middle East, the oil per barrel has come down to $11 or so. But this is probably the changes which are happening right now. But when you compare to the cost of electricity for running the same distance, it is still cheaper than what the prices are. We will see how this game gets played out, oil versus electricity. But definitely, electricity is a cheaper fuel option even in future. So less pollution, longer lifeline, less moving parts, and reduced fuel price. I think that's the pitch always for an electric vehicle. But even though we have all the good things, why haven't we adopted around the globe is a question which I get asked all the time. So challenge number one is what is called as range anxiety. Like I told you, 100 years back also we had the same issue in terms of how would you charge these vehicles, where all will you charge these vehicles. In India, we have around 80,000 petrol pumps all around India, whereas we have less than 500 charging stations all around India. So how would you go around is a big challenge. I think this problem will get addressed in the next years because of two reasons. One, the vehicles themselves will have a longer range, which will take care of it. And second is charging technologies are changing in a way that we will have a fast chargers to a level that you can charge your cars in a short period, and you may not really need to charge the whole day. I think that's current vehicles have that problem because they most of the cars in the on the road cannot travel more than 80 to 100 kilometers on a charge. If you have your AC on, the range comes down. I think that will get solved, but that's the current challenge. The time to charge, like I said, you the fast chargers are one expensive. Second, they need a huge changes on the grid side. So we really don't have too many fast chargers on the road. But right now there is an infrastructure planning going on to bring 50 kilowatts to 150 kilowatt EV chargers, which will make it much faster. but still they would need anywhere between 30 to 45 minutes to charge. I think that's a challenge which we will have. Price of the vehicle, it is mainly driven by the battery cost as of now, because 35 to 40% of your electric vehicle costs, not from the price point of view, from a cost, is the battery cost, the battery which is inside. The price right now in 2019 was around 150 plus dollars per kilowatt hour. Um, Going forward, it's expected that by before 2025, this price will go sub $100, and once it moves sub $100, we will have the vehicle prices, also the EV prices, will be comparable to the any other regular prices. So we won't then compare whether it is a EV or a non-EV. It's an automobile for you to buy and the choice. And with more options, you would probably make a choice between an IC engine or a EV. The time to switch from a gasoline, that's been a major challenge in many countries in UK and Scandinavia and some other places, because the current cars, what you have, or the current vehicles on the road have their own lifeline, and they are not. You can't swap them just like that. You're not going to junk them less just like that. So there is an expected lifetime of those vehicles, and only when they go to an end of life, you will see a lot more EVs being adopted. That's a challenge in some of the countries. Currently in India and few other countries, there is also limited choice of vehicles, whether it's a four-wheeler, two-wheeler, three-wheeler, the choice of vehicles are limited. I think that's a supply problem, but the market demand is existing. So I've been part of many discussions where we know there is a demand, but the problem is with supply. I think this will get addressed as we go along. Right now, there is a lot of imported components in most of the vehicles. I think this over dependence is also a challenge. The backing right technology, if you are from telecom, you always knew that there was always two competing technologies at some point of time, CDMA and GSM. Later on, we were looking at how it will migrate to 3G and eventually to 4G. But eventually, if you notice, one standard one and where we are. It's a very similar problem in charging standards right now based on the OEM. I will talk about it later on. There are multiple charging standards, and also the battery technologies. Right now, we go with lithium ion with a particular chemistry, but it's also expected to change. So, which battery and what kind of technology will you back on is a big challenge when you look at EVs at that point of time. And of course, the last topic is because it's a new industry, you have a lack of maintenance and repair networks. So to push, get a demand for electric vehicles, a lot of countries are taking different approaches. Most of them have been a policy intervention where you set certain emission standards, you set certain fuel economy standards so that it becomes stringent for fossil fuel vehicles, maybe fairly easier for electric vehicles. The idea is to see if we can move towards electric vehicle. There are a lot of financial incentives, like in India, we have a FAME 2 scheme running right now based on the vehicle and how it is built, you get certain subsidies. Cities also have access restrictions. Certain areas you don't want any other vehicle other than EV. Many of the cities have given some of them there. Many countries have put a timeline saying by 2025, Norway says, I will not sell any new IC engine cars. Very other countries have done that. What India is doing, I will talk in the next slide. I think that's something we are doing. On the consumer demand increase, one of the challenge has been, like I said, variety and charging infrastructure. This was a study done by Deloitte. Deloitte. If you notice, India, one of the major challenge right now is the charging infrastructure. Different countries have different perceptions, but in India, it's the charging is the major perception. So, how did the EV sales happen around the world? If you look at last year, in terms of EV as a percentage of total vehicle sale, Norway, the Scandinavian countries are way ahead. They are adopting, though they are oil rich, Norway is adopting electric vehicles in a big way. So, Norway, Iceland, Sweden, Netherlands, Finland are the leaders as a percentage of sale. But in terms of sheer number of vehicles being sold, it is China, US, and then only Norway comes up. So China is leader at one point in terms of number of vehicles sold, and Norway is a leader in terms of percentage of vehicles being sold. And just to compare in terms of the charging infrastructure available, China is way ahead because for they have also deployed a lot of three-wheelers and others, and they have a huge charging infrastructure in place. India is nowhere in this list because we our numbers are much smaller. In fact, even today, the 20% growth and nearly good number of two-wheelers being sold, but they're all very entry-level two-wheelers, and charging infrastructure is still not yet there. So what is it in India? Uh, Very clearly, the trends and the current adoption shows that we will be multimodal, we will be electric, and it will be shared. Multimodal is because metros, shared vehicles, all of them are coming in. You may not use one kind of mobility pattern when you go from point A to point B. You may use electric last mile connectivity to a metro station. You may use a metro, then hop on to an electric bus or a regular bus, and then at a last mile you may even use a bounce or a OGO to move to your last point. So it's expected that India will adopt this, and most of these now vehicles coming on road, whether it's an IC or whether it's a electric vehicle, are all connected, which is extremely good because we already have that happening with the new vehicles coming on road. And shared, like I told you, we're already there. I think that's a very important trend when we look at India is on par with global when it comes to the way we are moving towards the new way of mobility in India. So, but for me, there are four definite reasons why we will do it in a very different way and much better way. Is that one, of course, the need for doing it. We have top polluted cities in the world are in India, and moving towards EV will ease down that. I think I talked about Delhi already. India is a top three oil importer at this point of time, just right behind uh, China and US. We import most of the oil. This will moving to electric vehicles will be a big change for us in terms of GDP impact. Then you will always ask a question saying, okay, if we don't have oil, what about electricity? Do we have it? Very interestingly, India is a power surplus country overall. If you look at statistics, you will see that India is a power surplus country. And the problem is in the distribution, but if we can sort it out, I think we have enough power for our electric vehicles. And of course, there is another little challenge there. Bulk of our electricity comes from coal, but solar and other renewables are catching up. They're already 15%. I think that will be a big boost in the next 4 to 5 years. I think from looking at these aspects, it's going to be a big push even from a government and individual point of view to move towards electric mobility. What is also again very interesting in the last 1 decade is that India is now a digitally native country. That is, I think it doesn't matter whether it is rural India or urban India. All of us have telecom infrastructure to an extent that we understand data now. We can do a lot more online transactions and everything. So I think that will help us in terms of adoption, in terms of getting these vehicles on road. From a market segment, always we get compared with US, which is a very car centric market, whereas in India is nearly 85% is two-wheeler and three-wheeler centric market. So this market is slightly similar to what China would do, or very close resemblance to China. And we should never look at what's happening in Europe or what's happening in US to see what will happen in India. I think Indian market will evolve on its own. China has been deploying electric vehicles, two and three wheelers, predominantly three wheelers and buses for their mobility in Shenzhen, in Shanghai, in Beijing. There is a lot of data available now in terms of what they have done. Of course, the way they have approached the market is more government driven, but in India it will be more market driven. So we will see how the dynamics and what technologies will work in India. And like I said, we have nearly 230 million motor vehicles now, and it's increasing. So this number is a big number when we talk about 80% of these vehicles. So from government, we have seen now a big push for EV adoption. There are a lot of announcements that by 2024, 23, and 24, three-wheelers will all be electric. We will not have any more IC three-wheeler available in the market. These are not yet policies. These are announcements. It will also be that 150cc and below two-wheelers will also be only electric by 2025. So these two are already announcements which are there. FAME 2 has been a 100 billion rupees budget. That's around 10 crore, 100 crore, sorry, 1000 crore budget for clean energy. And you typically get around 20,000 per kilowatt hour subsidy on electric vehicles. I think that's reducing price to some extent. But my personal opinion, subsidies are always good. But I think once there is a meaningful value in the whole vehicle ecosystem, people would buy and adopt to it. It will always not run on only subsidies. But at this moment, it's a big boost in terms of adopting electric vehicles. In future, also 20% of new building parking plots slots are expected to be reserved for electric vehicles. There's already an anticipation that you need to build the infrastructure because it's not just parking reserve; it will also have charging reserve. Like in California, you will have a dedicated lane. In probably in future, there will be dedicated lanes in India also for electric buses because it's not about only cars. We are talking about buses. We are talking about two wheelers and three wheelers. So let's, with that context in mind, let's look at what these technologies are and what we are talking about. Before I jump into this, I just want to say one thing, which is what we in our company very strongly believe in, is that electric mobility is coming together of three different industries, very strongly interlinked, and that is unless they work together, it will never succeed. One is automobile industry, which brings the vehicles, which converts vehicles into electric, battery technology coming along with it, becoming smart batteries. The second important industry, which is already a large industry, is the electric industry, electricity industry, or the grid, where they have to adopt to fuel these vehicles, because as of now, grid industry and automobiles don't necessarily talk to each other, because it's been oil and gas and vehicles. These two industries will have to come together, which means a huge setup of infrastructure to be built, which are electric vehicle chargers, battery swap stations, renewables integrated. It's a whole lot of changes to be done there. Third aspect, which we should not forget, is that the digital economy comes as a third industry, which connects all of this and makes quite a few workflow changes and the business flow changes, which makes both of these viable. So we need to keep in mind that changes will happen across all these three, and all of them need to come together. So what I've done is I'm going to give you these three bubbles in its own isolation. What will happen in automobile, grid, and then with digital, and then we will see how the whole thing shapes up. From an automobile perspective, there are three types of classification people use. One is hybrid electric vehicle, second is plug-in hybrid, and then battery electric. For all practical purposes, when I talk about electric vehicles now, I am at the third category, which is battery electric vehicle. The subtle difference between the two is when I look at hybrid electric vehicle, there is no means to charge them. There is a battery. It is used within the vehicle when there is a bit of a regenerative braking there and charging of the battery using a motor inside, and that is used for range extension, sometimes for other internal needs of battery within the car, but that's a hybrid vehicle. uh, Plug-in hybrid is the same thing, but you could also charge the battery from outside. The battery capacity increases in this, so there is a huge range extension. Toyota Prius and a lot of other cars are available in the US market, global market, where typically it's a gasoline engine, but you have EV on top of it to give you a longer range and also make it cleaner, much more cleaner and clear and greener. But where we see completely green is, which is a 100% electricity from the grid, and these are the BEVs. Most of when we say electric vehicles, right now we are focused only on the BEVs. So what are the components of an electric vehicle? It's actually, like I said, vehicle itself is very simpler. I've taken a car. You can replace a car with a two-wheeler or a three-wheeler or a bus. Components are very similar. What technologies are required are very similar. It is much, much simpler than what a regular automobile is. So the fuel tank or the fuel is the battery. So battery can be flat, battery can be boxes, battery packs can be of any different shape. Cars keep it below the seat. Auto rickshaws keep it below the driver's seat, but more in a square form or a regular lead acid cell kind of a form factor. Certain vehicles keep it in a square factor. So it depends which form factor it takes. But it's a lithium ion batteries which is used. And typically, if you open up this battery packs, you will find very similar to a AAA cell connected in series and parallel with a battery management system on it. So it looks simplistic when you open it, but it's extremely sophisticated to manage the voltages and get the right currents to get the motor running. Uh, the battery typically gets connected to an inverter because it's stored in DC. You want an AC current thing, so you will have a power control unit which has a inverter component which gives electricity to the electric motor. The speed is varied using the frequency change, and all of that is used to manage the electric motor itself. That's where the vehicle control or the power control unit comes in. And regenerative braking is used in most things because electric motor can also work like an generator. So when you're braking, it actually generates electricity and then it's stored back into the battery. That's used now in most of the vehicles. So the simplest system is battery, inverter, and a motor. I think that's the component system. As you notice, inverter and motor come from electric industry for a long time. So these are known technologies. We are now trying to use them so that it works well within an automobile system. Batteries are coming from a slightly different industry. The lithium ion batteries are used in our phones, laptops, and various other components in a slightly different form factor, more flat form factor. But here it is used in a slightly different form factor. But that component itself comes from a different industry. But To get these batteries charged, you also need a charging inlet. So sometimes you have a fast charging inlet, which is a DC charging. Sometimes you have a AC charging inlet, which has then an onboard charger, because then you'll have to convert the AC to DC, and then it gets charges the battery. So you either have an onboard charger or a quick charger. So some of the vehicles in the market right now, if you look at Mahindra or Tata vehicles, some of them have both. Some of them have only AC charging units, or if it's an onboard charger, it's a slow charging. It takes almost 8 hours, and that's one of the problems. Like I talked about, long time of charging. Fast chargers take anywhere between 45 minutes to 1 hour to charge a regular car. Yeah. So just summarizing: battery, inverter, motor, regenerative braking I talked about, and the power control unit. So these are the typical components in any electric vehicle, and it's fairly easy to design. But the most complicated part which comes in is in terms of the battery and the battery management system. Uh, and that's where a lot of work is happening right now to get the range, to get the life of the battery to be longer, because there is always, I'm quite sure all of you know, your phone battery will die after X charge cycles. And that's the same challenge you will now face in an electric vehicle. Though rated uh, cycles will give you 5 years to 7 years of life of a car, but it is not comparable to what you can get with an IC engine. So there is a lot of research going on to see how to get this working, and even that lifetime can deteriorate based on temperature of where how you operate, because lithium ion battery is susceptible to temperature changes. So if you're in a very hot place, it may give you a slightly different range, slightly different life cycle. So there is a lot of activity and work going on in that. Also a lot of work going on in getting the motors in place, how it would work, onboard chargers. So work going on, but you can assemble an electric vehicle pretty fast. If you have understanding of these components, you can bring about an electric vehicle very quickly. What are the vehicles right now on the road? Maybe you start seeing many of them. You may not recognize them. Ather is the very known, well-known brand, which is more of a premium brand. But you will see a lot of vehicles on road from Ampere. It's Greaves Cotton owns the brand Ampere. They have many, many models, and you'll see them on the road. Uh, and Bajaj launched one, TVS has launched one. So most of the standard OEMs are also launching their own two-wheelers. On three-wheelers, Smarty is in Delhi, Clean Motion in Delhi, Mahindra Trio is in Bangalore and in Delhi. You see a lot of three-wheelers in Delhi, Hyderabad, Pune, and many cities. In Bangalore, you may not see many of them, or in Karnataka, you may not see many of them. Two-wheelers, most of these two are manufactured in Bangalore, so you see many of them on road. What is interesting is you may not see most of the two-wheelers on road used by passengers, because other than Ather, many of the two-wheelers are now used by ride-sharing companies like uh, Bounce and Wogo and others. You also see a lot of these vehicles modified into logistic carriers. So many of the e-commerce companies, when they come to deliver goods to you on a two-wheeler, it is typically a electric two-wheeler, but there is no sticker or anything on top of it which tells you it's an electric two-wheeler. But it, because it looks more or less the same as any other two-wheeler, but they're all electric two-wheelers because there is an economic sense in doing it. If it is a car, I mean, maybe let me come to car. So also cars, when you see passenger mobility, people are not yet buying a lot of cars. Verito was one of them, and Verito no longer is available in the market. But Tata Tigor, Hyundai Kuna, MG Hector, a lot of other vehicles coming in. Mahindra has a roadmap of new vehicles coming on road. Same with Tata. Tata Nixon is on the road. Hyundai is planning for many. So in another 2 years, you will see a lot more passenger cars on the road, which are better designed, better equipped from IC engine too. In terms of range, for instance, Kona gives you sometimes 300. There are some range also up to 500 kilometers. So it's as good as your IC engine in terms of the one with one single charge you can go that distance. Tigor and Verito don't give you that range because they are not designed for it. They're designed for 100 kilometers to 150 kilometers. That is where they need more faster, no, more frequent charging. And these vehicles also you will see them on road, but not in as an electric vehicle, because many of these vehicles are used by corporate fleets now. Company cars are all converted to electric, so many cars are also running in this format. There are many buses being launched in many cities. BMTC and KSRTC are also discussing and running a fleet to get several hundred buses on road in Bangalore very soon. You may see them in the next half a year to 1 year. Olectra BYD is one of them who had got the contract, but they are now running it in Pune and in Hyderabad. This is the Chinese, the world's largest bus manufacturer, so that vehicle is already here. Tata Motors has it, Ashok Leyland, JBM, the Mahindra, many of them have electric buses coming in. So one of the transport areas where electric vehicles will get adopted very soon is on the public utility buses. The reason being, particularly in car, I have the numbers where if the car runs 200 kilometers plus in a day, electric vehicle gives you your return of investment within 1 year. That's a model we have done. We have validated with many players, and it's a very well-known number that 200 kilometers is more like a benchmark. If somebody is running 200 kilometers a day, electric vehicle makes sense absolutely. So most of the fleets, most of the taxis will move to electric in a short period. Same with electric buses, they will also come in very fast. Also, there is, of course, micro mobility, the last mile mobility, where you will also see electric vehicles of different form factors, scooter to mini vehicles. These will all be electric and they will all be coming up to give you the personal mobility experience in the last mile. There was a debate. I was in another long discussion with people before this call where we were debating in terms of what would happen after the lockdown opens up in India, particularly. Would people go on a shared mobility? Will they sit now in cars with three others? Will they now use a car which is already used by somebody? Or will they start preferring such micro mobility for last mile and use metro? So there was a debate on this whole topic. I don't think there is any one answer. We'll have to see how we behave and how we will do it. Of course, there's another topic which was based on what happened in Wuhan is that we may all go and buy a lot of two-wheelers which are electric is an expectation, which is the positive upside of it. The negative side could be that people probably don't even want to go to work. So there is a lot of debate by different people to say what would happen in automobile industry, in mobility patterns in India after the lockdown is taken off. So that's, I think, a topic for all of you also to think and debate because it's something which will impact the whole way of doing things. So that's one industry, like I said, automobile. I want to now jump into what's the changes in the grid side to make these vehicles run on the road. So it's a sort of a commercialization dilemma. Should vehicles come first, or should we have the charging infrastructure? If you talk to people why they don't buy the vehicles, they tell you there is no charging infrastructure. But if you want to invest in a charging infrastructure with the EV chargers, electrical equipments, they're expensive on public places. You have no business case unless, again, we have a modeling done which says that you need to have X charging sessions per day. Only then it makes economic sense for anybody to put money into it, whether it's government or private players. So who would do it? Who would bite the bullet first? My take here is that EV charging infrastructure will come in a faster way because unless you get that in place, I think the adoption will be slower. EV fleets, the logistic fleets and passenger fleets are helping to bring these chargers in place. I think that will happen first, and then vehicles will come in a much faster way because then there is nobody will talk about a range anxiety because you will have charging infrastructure wherever you go. So to explain EV charging in a very simple way, you will hear two terms: AC chargers, DC chargers. I think I already mentioned it when I talked about the vehicle. The main difference is if you have a battery, if you want to charge it with an onboard charger, if you move the charger which converts AC to DC inside the vehicle, it becomes an AC charger. Outside is AC charger. AC chargers are very, very simple electrical equipment which takes your wall input and gives it to the vehicle, or sometimes you have a little more voltage and current offered, but all the conversion happens on board. But then the vehicle's weight increases because you add the onboard charger on the vehicle, and the time it takes, and you can't add a bigger charger inside the vehicle. So the charger which will be added on board will be of a slow charging capacity. It will convert and give very slow charge to the battery. So this is typically used in home environment, parking environment, another environment where you can park the vehicle for a longer time. But when you need fast chargers, you need electrical equipment, which is DC fast chargers, which convert AC to DC in the charger and give direct DC to the battery. So these are the places where Tesla started off with their superchargers, but here in India, we are not talking about superchargers, but with the fast chargers, we can charge our cars anywhere between 15 minutes to 45 minutes. But again, it depends. It's a very heavy electrical equipment. If you want to bring a bunch of this electrical equipment, let's say if you want to bring a charging park with 150 kilowatt four, five of them in one place for a bus charger, you almost need to get a substation around it because it cannot run with an existing grid, with a distribution network. So it has its own challenges. AC chargers don't have that challenge. So, and it's much more cheaper. DC chargers are probably 20 to 50 times more expensive than the AC chargers. So market will have a mix of AC and DC chargers. AC chargers where you can afford to spend more time, DC chargers where you cannot afford to spend more time. This is also the place where, though I'm not going to get into that topic at all, there is another alternate thing in India we are working on, which is called battery swappable systems, where instead of charging in either way, that approach we are trying to take for two-wheelers and three-wheelers, not for vehicles beyond that, is that we can remove the batteries when you come in, and this DC charger will actually charge batteries instead of giving electricity. We can have it's like a storage, which is already common in the electric industry. In the storage, we can charge 20, 40, whatever number of batteries. And when the vehicle comes, remove the battery and replace the battery, which is much faster. But it comes with its own challenges because the charging equipment then is even more heavy because it has to charge 40 batteries at a time or 20 batteries at a time. There are a whole lot of challenges, the swap station design, ergonomics, the grid requirement, everything is a big challenge. So right now it is used only in two-wheelers and three-wheelers. Just to give you how to spot them, two-wheeler chargers are as simple as a laptop charger, slightly bigger. This is what they give you along with the two-wheeler. You can plug into your home any socket and charge your vehicles. Fleet guys, all of them use the same thing. These are AC chargers. This looks bigger, but actually it's a smaller equipment. They come with a specified gun. There is a protocol managing it, all of that in place. So AC chargers are much more complicated. The high voltage DC chargers, these are very big in size. It's large cabinet like a data center. It's I'm just in the image, it looks smaller. It's a much bigger equipment. So you can have one gun, two gun, multiple guns. All of them are possible. This is a typical battery swap station, a very similar equipment, but here you will have 10 or 20. It's a 20 slot DC swap station where you can see there are 10 here and 10 at the back. The idea is that the batteries are designed in such a way that you can plug the battery out and insert it into your vehicle and put your battery back in, and then it will charge. So it has a lot of technology inside its connected boxes. All of them are connected boxes managed with a protocol and on the electrical side and also on the communication side. The challenge now starts is that when it comes to cars, there is no one standard of plug because all of these are heavy electrical equipment. You need to plug in a car plug into the car to charge it. So AC, there are type 1 chargers, type 2 chargers, but AC typically we are now using a standard which is Chinese, which is GBT, GB by T, and that's the most popular charger format. Most of the Indian vehicles use a GB by T. It already can tell you that we have actually picked technology from China in that way. DC chargers is where we are now looking at. CCS1 is a slightly older one, which is used in North America. We are looking at CCS2. Chademo is coming from Japan. CCS2 is from European vendors, and China still uses GB by T. In our market, we have a mix of all three. You can imagine all the Japanese vendors use Chademo, or also Hyundai uses Chademo. CCS2 is by all the European vendors and the rest of the players. Most of the Indian players use GB by T, and all the Chinese vehicles also use GB by T. Tesla uses its own standard called the Tesla connector. So this is a standard challenge because if you are investing in an electrical equipment, you need to now have all kinds of chargers. Otherwise, some of the vehicles cannot charge in your charging station. Then that increases cost, and that's the challenge. Indian BIS standard now says that we can use CHAdeMO or CCS both, and GB by T only for certain class of vehicles. The lower end of cars will use GB by T. Most of the other cars will use either CHAdeMO or CCS. So many of the chargers now have dual port capability. Then you can charge either of these vehicles. Yeah, so all these chargers are no longer like a fuel pump that you go and somebody else fuels your vehicle. All of them are digital now. It has to be, it's a self-serve mode and it will be in remote places. So it's expected that you go, you authenticate digitally. You have to plug in yourself. You have to get electricity. You have to pay at the on the spot with an online UPI or a payment gateway. So all of this is digital and automated. And there is also a lot of automation with grid at that point. So EV charging infrastructure is now much more digital and much more self-serve. It's all connected to cloud and authentication has to happen with cloud. If it doesn't authenticate you, your vehicle cannot get the charge. I think So that brings a lot of digital technologies along with the charger. So to make it truly clean, there is also a lot of push to say we are doing all this charging parks. Can we make them green? So solar parks are coming in where EV charging equipment is used along with the solar parks. But the challenge here is that you need to store the energy unless the cars are there all the time or vehicles are there in the parking lot. That adds to the cost because otherwise solar it has to be stored or given to the grid. So this is something which most of the players are grappling with. But this is coming up and in many places you will see it. And this is the strong use case for battery swappable system because battery swap systems are storage. So the two-wheeler, three-wheeler fleets, when they're looking at it, they're all looking for solar integrated systems. So very quickly, your fuel station is no longer going to be a petrol pump. It can be at your home, work, parking, public place, highways, hubs, and sometimes wherever you are. There are certain players who are also having battery on the move. So wherever your vehicle is, it will come and give you a fast charging in half an hour. So all kinds of models have been tried out around the globe. What I wanted you to remember is that charging will happen anywhere now, not just at your home. So won't spend too much time here. Different vehicles, autonomous cars will have a different requirement. Uh, there are a lot of drones being planned now. Drones also are electric. They need a different charging. There are wireless charging pods being designed, solar charging panels on top of vehicles. Uh, the road being made as a charging with contact charging on the road. So many different types have been tried. Pantographs are being tried for buses, lamp posts where if it's already an existing lamp post, can we add solar on top of it, keep a small storage below, two-wheelers, three-wheelers can be charged there. Vehicle roofs, solar based are also being planned. So there are many different topics on going on based on that type of vehicles. I'm keeping a check on time, so I'll try to quickly wind up now. On the digital side, one of the biggest requirement right now is on telematics, so which is where it will add a lot of load on the telecom network. And 5G is really apt at this time when EV booms in. Every vehicle will have at least three or four IoT devices which needs to talk to the cloud, and it already runs right now with 4G. But I think with much more, all the vehicles going towards it, 5G would be majorly needed. All the players are investing heavily in it. Like you see, the APAC is one of the places where China, India, everywhere, all the vehicles are getting connected, even the traditional vehicles and also the EVs. Other important technology digitally is on the battery management system. This is the software which runs on the battery pack, which help in managing the whole battery management, whether it comes to SOC, state of health, state of charge, temperature, voltage, thermal management. It manages all of that, and also the throughput in terms of current and voltage. It is the one which balances, and it also is digitally connected to the vehicle control systems through CAN. And we are also working on certain cases where the BMS also comes with an integrated telematics. So this is another area which is very interesting, hot, because we want to make this work because this digital technology can make EVs much more viable. Like I said, on the charger side, the complete charger is managed centrally right now, and that is an extremely important element from the grid point of view because it's not a pure software. It's a lot of automation and analytics inside because it controls how the grid responds, how the demand is pushed to the grid. There are dynamic load balancing, dynamic tariffing. A lot of things come up on the grid side. I think software is one element on the user experience. Second element is a lot of deep tech in terms of how the grid gets managed. So, a couple of future topics, challenges in India, battery price, chemistry, raw material dependence, because we were dependent on oil all this time, but with lithium ion, there is a lot of dependence on China and few other countries. I think that is something as a country we need to be aware of. Once the lithium ion batteries are used in the vehicle, the second life recycling is a big opportunity. So I would urge if any of you are interested in this topic, this is the topic to look at because all these batteries will lose life in the next 3 to 4 years. So it's a big opportunity for companies and startups to look at. A lot of vehicles and chargers are being imported from China, like the mobile phones get imported. But there is, I think, these technologies can be indigenously built. There is a lot of push by even government of India and a lot of other players, VCs and others, to see if India can build most of this because it is something our market is unique and we can make all this equipment. The petrol pumps or the fuel pumps will also come in. Where will it come? How will it demand? Is a challenge in India because real estate is very extremely expensive and most of this equipment need real estate. So that's some point to remember. And like I said, Indian ecosystem of innovation is extremely important. So what are the critical success factors when we look at ecosystem of EV? On the charging side, the connector industry itself is extremely important. It depends how this works, we will make a success. On the grid side, how the renewables and how the grid responds to EVs coming on. There is, of course, a lot of topic on V2X, vehicle to grid coming in, where vehicles actually can help to remove the harmonics on the grid. The vehicles can come in to even give voltage stabilization to the grid. So there are a lot of other topics coming in. Telecom companies, there's a huge opportunity for them because if 5G and 4G work very well, I think it will lead to success of these networks. Batteries, we talked about it, battery makers and battery farmers. So both of them, the way they build the cells, the way they build the packs, and the way they build the BMS will make the success of EV. And with EVs coming in, there are new parts. There are no traditional mechanical components coming in. There are newer components coming in. So there will be a new industry and a new market for new component players. Existing ones might migrate, but it's going to be different and new. This is just to give you an idea on how the whole thing works. Yeah, I think I just wanted to end with this. We strongly believe that on the mobility side, future is electrifying. There will be electric vehicles on the road. We have started the whole journey. There is no looking back. I think most countries in the next decade or decade to two will transform their vehicles into electric vehicles. You may not see all the vehicles converted to electric by 2030, but expectation is that at least 10 to 15% in most markets will convert into electric. And in the next say, decade, most of them will get converted to electric when the life of current IC engines will go. Puneet, back to you. I know I took
Yeah,
a little more time than planned. I can take some questions.
yeah. Thank you very much, sir, for providing your wonderful perspective on electric vehicles and its impact in 21st century and especially in India. You have nicely covered the history of electric vehicles and challenges faced in last 100 to 120 years. EV adoption challenges, price competition with fossil fuels, then future of mobility in India, which can be a multimodal, electric and shared. Also, e-mobility market deployment models and various companies developing the EVs were covered in your presentation. Challenges of multiple connector types, future fuel stations and associated technology, then coming to battery management system, and at the end again in the challenges in the Indian market and innovation happening in India. I also agree that future of EVs is electrifying. Thank you very much for nicely summing up this webinar. Now we will go quickly to the questions because we are already at 7 and I have already received more than 15 questions for you, so I hope you are having time to answer that.
Yeah, I'm okay if everybody is okay for 5 to 10 minutes, I can answer some. I haven't seen all of them. I see few of them. If you want, I
Yeah.
can start from the bottommost or I can start from the top. So no problem.
No, I have already copied in my slide. So I will
Sure,
just go one by one and you can answer.
sure, sure.
Question is, how would mass electrification in future affect the grid?
Uh, can you repeat again, please?
Yeah.
How is?
How would mass electrification
Yeah.
in future
Okay.
affect the
Okay.
grid?
I get the question. So
Yeah.
yeah. So like I mentioned already, most countries, particularly also in India, our grid is already ready to take such an electrification. India also there is a lot of investment to get solar farms in place across the country to augment the current capacity. In the next decade or so, even though we go completely electric, I don't see any major challenge in most of the countries in terms of their grids being responsive to the electrification of the mobility. So I don't see a problem at this moment. There are data available. If I can share some of the reports which gives you the data around it.
Sure, sir. We will be happy to have it and then we will circulate to the attendees.
Sure, sure.
Next question is, what is the future of EV batteries? Currently, we use lithium ion and lithium phosphide batteries in vehicles which have less range. Do you think gigawatt batteries will come soon?
Like I already mentioned, so that's a topic everybody is working on, everybody is trying. There are solid power batteries, there are different chemistries being. I'm not picking any one chemistry right now. There is also ultra capacitor based batteries being designed. So, hybrid ultra capacitor batteries being designed. So, there are several technologies being tried out. At this moment, the most viable technology the most stable battery technology is the lithium ion for the ranges and what we are looking for. So I think at least for the next 2 to 3 years, we will only have lithium ion in the market. But by that time, depending on who does what kind of R&D and what kind of viable systems come out, we may change. So that's something very difficult to predict at this moment. But only thing I can very clearly say is that it's lithium ion at least for the next 3 years.
Okay, so thank you. Now, next question. What is the typical life of battery used in electric vehicles currently? What is the status of recycling technology? Else, we will see another major headache on hazardous waste.
Yeah, absolutely. I agree with you, and that's why I also put it as one of the challenges. So the life of these batteries are anywhere between, depending on the use, like I said, there is no one standard duration. You can keep it as 5 to 7 years. In cars, in two-wheelers, it could be slightly lesser, based on again how it gets used, because the life of the battery is also based on how you use the vehicle, unlike the IC engines. The second life topics are already being discussed. We are also working on several topics where these batteries are recycled for home use, for lighting, for stabilizing the grid. There are multiple use cases being tried. That is still they are usable because when I say automotive grade will go out after 5 years, but the batteries themselves are of so good quality that it can be used still for other use cases. But at the end, it has to be recycled, and those are certain companies coming up to recycle in a way that it will be lithium will be recycled, and some of them will be recycled to use for battery manufacturing again or other use cases. So those are the companies coming up in terms of recycling.
So they are going to create another kind of ecosystem for battery management.
Exactly. So that will
Yeah.
come post this. Yeah.
So now, sir, next question is there any regulations in India for connecting the EVs to residential buildings?
Yeah, I'll quickly answer this. 2 years back, Indian law had a case that electricity cannot be sold by anybody other than the discoms or the distribution companies. But April 2018, it has been relaxed in a way that giving it to an electric vehicle is considered as transfer of electrons. So it is not sale of electricity. That's how it is worded. With that, anybody, you, me, anybody can set up an EV charging infrastructure in front of your home. Only condition is that you'll have to have a special meter from the discom because they'll give you a different tariff for it. And right now there is no regulation on what you should charge, but eventually there will be a regulation on upper limit of what you can charge anybody. But you will have to pay X different tariff for EV charging, a different meter, but anybody can install EV charging infrastructure.
Oh, wonderful. So, sir, now next question is what steps must be taken in urban planning and development of tier 2, tier 3 cities for an electric vehicle future? I think
Yeah,
they are talking about
so
smart cities.
correct. So EV is now getting as a essential topic of every smart city project. So main topics are grid infrastructure building in terms of charging, because there is nothing else you need to do. Because it's a lesser maintenance of vehicles, the service centers and others can be managed. We are also working with certain players who are also looking at how to take electric mobility to rural India. But here the mobility would be in terms of auto rickshaws, cycles, electric cycles, and electric two-wheelers of lower capacity because they don't need such a long range in cities. And we are also looking at smaller shops setting up electric vehicle charging infrastructure for these vehicles because you don't need heavy equipment and not much investment. So there is a lot of planning going on to bring it into tier 2 and rural India.
Very good, sir. So now we will go to the next question, which is again related to the inclination level of existing automakers to switch from IC engine cars to electric vehicles.
Yeah, so this is a very typical challenge, right? Because
Yeah.
this is your bread and butter. How would you switch to a new thing? But if you notice, every OEM in the world has already put their roadmaps. There are a lot of them who have stopped making diesel engines because the stringent fuel efficiency and emission norms is making it unviable for making the diesel engines of that type. So instead of R&D in that, everybody is moving already to electric. But what you will see is with all the installed plants and capacity for regular diesel and petrol engines in India, most OEMs are not making too much of noise because they want to make ROI on those equipment. But in parallel, all of them have a portfolio of electric vehicles of their own popular standard models in electric. And my expectation is 2021, 22, you will see many, many more models on the road when they feel it is the right timing. So it's a matter of a year before you will see most of the popular vehicles in electric version.
Yeah. So for students, I will just tell ROI means return on investment.
Yeah, return of investment, sorry.
Yeah. So because sir has used the short forms, I thought that I will explain to students. Yeah. So now coming to next question, what are the kind of drivers used for powering electric vehicles? What is the progress in developing drivers for electric vehicles?
So
These
here we're
two
talking
questions.
about
Yeah.
the drives, right? The motor drive motor. So that's powertrain is what
Yes.
we're talking about. Uh,
Yeah. Yeah.
so see now there are multiple companies coming with the larger OEMs have their own powertrains with the drive built in and they give it as a component. Many are picked up from existing market in China and the rest of the integration happens in India. But there are certain startups, certain companies who are building their own drivetrains. Uh, there is work going on all of that. So how efficient they are, how well they perform on Indian roads are yet to be seen. But you already know the most popular two-wheelers are already from startups. It's not from traditional companies. It is Ather. Ampere was a startup. Now it got bought by a larger company. TVS and Bajaj have come only much later in the market. So indigenously, a lot of startups and younger companies are researching and building these. It's happening in India. So we will see much more of these.
Very good, sir. Now, next question. I'm just quickly reading about questions because we are having a lot of questions. So, do we have hybrid electric vehicles, HEV, PHEV vehicles in India? Which models are available on the top?
So Toyota had a Camry with a hybrid, but I think it doesn't sell in India right now. Um,
Mhm.
but on the hybrid, I can't think of pure hybrid in any other vehicle at this moment. And uh, I think Hyundai also had one model. I don't remember the model, but most of them are out of market. They don't sell right now in India. Most of the models coming into India are purely BEVs, whether it's Hyundai Kona, uh, Mahindra vehicles, Tata vehicles, Nixon, all of them are battery electric vehicles. We don't have any more HEVs and PHEVs.
So, you discussed about component connections in electric cars. So, question is, how is the component connection in electric bikes? They want to know about electric bike
As I
component.
said, conceptually it's the same. Of course, the form factor is different. The way the drivetrain is designed is different. But I only give the logical blocks for you. But if you just Google around an electric two-wheeler, you will see the same components but in a different form factor from a car.
Mhm. Next question, which is the popular electric motor used in electric vehicles?
I don't want to take brand names now, but there is nothing like popular. Everybody is trying their own either their own drivetrains or they buy from certain models. You can assume that most of the leading global MNCs have drivetrains which are extremely reliable, but they're very expensive. So most of the vehicles right now on road don't use them. They are using either Chinese or custom made. But I don't want to take a brand name here in the presentation.
Yeah, I can agree. Why BLDC motors cannot use? So the battery DC need not have to be converted to AC for battery. I think he was writing something. So I will again read it again. Why BLDC motors cannot be used so that battery DC need not have to be converted to AC for better efficiency?
Yeah,
This is
I
writing.
agree with you. There are some of the vehicles coming with that VLDC motors. It's happening. But at this moment, the DC motors are the most popular. But this is another alternate thing coming in. But I think there is some challenge in efficiency. I'm not an expert on that area. So I don't want to answer without much information. But we do have certain vehicles with the AC motors.
Yeah. Now again, very hot topic about fuel cells. They are asking what about fuel cells in a BEV?
Yes. So fuel cell is the alternate to EV electric based vehicle. Toyota is the leading OEM which is pushing this technology. This is always seen as a competitor for electric vehicle and could it be a replacement? Yes. Is it available in a shape that it can come and replace electric vehicles? No, because even Toyota, if you notice, which has been the flag bearer of fuel cells, recently tied up with BYD for electric vehicles in China. So we will see how much they advance and how reliable they are, because then instead of charging station, we will have fueling station where hydrogen can be fueled. But at this moment, it's the battery electric vehicles taking the lead compared to the fuel cells.
So are there future possibilities for on-the-go supplementary charging technologies like solar cell or kinetic energy recovery system?
My answer is yes, because I put it also in the last slide of charging. If you notice, I said it's also possible to use solar roof, on-road charging, all of that. Answer is yes. All of this has been tried. There are some trials going on in Nagpur at this moment.
Again, a question on smart cities. What are the plans for EV charging lanes for smart cities in India? It will make sense in inner ring roads to have such lanes so that vehicles will charge on the move.
Yeah, answer is yes, you're right. But this is all inputs being taken by the smart city initiatives. They're all looking at it. But remember, if when I talked about the roads built specifically for electric vehicles, is where we are trying out various charging technologies on the road, whether it could be done. I think that's the plan. That's the plan. But right now, none of these technologies are viable. But smart cities are already looking at possibilities of dedicated lanes for electric vehicles.
So again, is there any work where the charging of the battery can be done using solar?
Answer
Again,
is
answer
yes.
is yes.
Yeah,
So how do we know that we are not leaving a larger carbon footprint with EV, since an analysis shares that the process of electricity generation produces higher pollution than the regular efficient IC for a given distance traveled?
Um, Prithvi, the answer is yes. There is this debate going on in terms of what we are doing. Is it going to give a lesser carbon footprint? In fact, there is also a report which shares that if you take the overall production of electric vehicles from batteries to the amount of grid, the way electricity is utilized, the carbon footprint is probably the same as using an ONG and an IC engine. But also, my sometimes my dilemma is also that we are reducing the pollution in the urban areas, but probably we increase the production of electricity, so probably we increase the pollution at the source point, point of generation in power plants. So this is going to be more of a debate going forward till we find more efficient energy systems. I think this challenge will continue. I wouldn't debate or I wouldn't say that EVs are better, will leave a better carbon footprint, but that's the hope. That's what everybody is working for.
Another, I think, answer is going to be yes. Do you think the EVs are impactful in India since we get 70% of our electricity from burning fossil fuels?
Yeah, that's absolutely yes. That's the one of the pitch I had saying that is why we need to move.
Yeah. Vehicle to grid with bi-directional charging points. What are the current plans in India?
Yeah, so V2G is a topic which has been hotly talked for probably more than 5 to 8 years around the world. It is not very successfully deployed anywhere in Europe and US. So India has been very cautiously approaching it. There are talks, there are discussions going on it, but right now nobody is actively working on it. We are one of the companies which work on that area, but no real commercial deployments of it as of now. But eventually it will happen. All the topics are being discussed, but not yet in a big way because we still need enough vehicles on the road to get these things on the off the grid.
Yeah, so now we have come to the last five questions. EVs are coming to Indian market, but is our distributing electrical companies are ready for these connections mainly for residential connections?
Yeah. So Mahantesh, like I explained, if you're it's a residential, you need to get a specific license, a meter. There is a whole lot of confusion now in terms of how to do that because to get that special connection, not all people in your locality, the discom, let's say in Karnataka or in Bangalore, Bescom, not everybody might be aware. There is a guideline for doing it. The deployment has been a bit of a pain, but this will hopefully get sorted out in the next year. There will be very clear guideline by most state governments as to how it will be done and the tariff and the meter. Like we have smart meters deployed everywhere, you will have a new net metering along with the guidelines for getting the connections at home. This will be a different line from your home connection with a different tariff, because at this moment sometimes the commercial tariff is deployed, which is 16, 17 rupees. But the idea, which is already announced in Delhi, is that EV charging will have something like 8 to 9 rupees per unit. But there is also an announcement which says it can go down to 4.5 rupees. So it's all still under flux. It will change.
Means, just 1.5 to 2 twice the existing rates what we are using for residential purposes. Another question is IEEE has any standardization in the field? Looking at the many different connectors here, I was thinking whether IEEE has made an attempt to come out with standards as happened in the Ethernet.
Yeah, so Jai Krishnan, IEEE does have certain standards in the EV space on the electrical side, not on the automobile side. So on the connectivity standards, there are a whole bunch of standards which come in. Many of them are still not standardized by either ISO or anybody. These are all currently IEC recommends it, ISO recommends it, but these are all industry consortium based standards for connectivity when it comes to connectivity standards. IEEE, however, has open ADR standards, which are connecting the smart grid to the EV ecosystem. All of those are IEEE standards. But on the connector side, no, IEEE does not have anything.
Now, next question, sir. With EV and autonomous vehicle concepts, the traditional mechanical focused industry need to transform. Electronics and softwares are going to rule, and whether these companies are reskilling adequately.
Yes and no. I think most of them realize that they have to change. Many of them have their own strategy teams working very heavily on electric vehicle topic. You go to any OEM right now, this is on top of their mind. This is the top of their agenda. They will all talk to you on that. Do they have the capabilities on digital technologies, software, and others? No. Is it good or bad? I think it's still okay because India is the hotbed for digital technologies, and we have enough number of startups, we included. We all are offering such solutions so that it makes it easier for them. And yeah, together as a, I think one thing we always say in our business is that electric vehicles is going to be an ecosystem play. No one person can build everything, and anybody approaching that will have a big challenge. So when you play as an ecosystem, I think we are very well equipped in India.
Okay. Now, question from Suresh Jangam Setti, sir. Will India be an indigenous manufacturer of EVs? If yes, then can we have our own standards for chargers?
Uh, Suresh sir, yes, answer is yes. That's what we are hoping and pushing everybody. So, Indian government also from BIS launched two standards. I didn't actually go into those details because that gets very heavy. There is a Bharat AC 001 and Bharat DC 001 chargers with specifications on how many kilowatt it should be, what protocols it should be. It is available, but it is slightly that's where the connector is where they put both of them, CHAdeMO and CCS. AC chargers can have GB by T. But what is challenging here is that these chargers are being mainly manufactured by Indian vendors. I'm not again taking the brand names. Most of the Indian vendors have AC 001 and DC 001, but these are very well suited for slow charging scenarios. And DC 001 goes only up to 15 kilowatts per hour. So these chargers are done by Indian players. Most of the global companies are not yet making these chargers. So it's an opportunity for Indian players to make AC 001 and DC 001. And most Indian tenders by government running right now ask for AC 001 and DC 001 chargers. So answer to you is yes.
Okay, sir. So now by this time we have added three more questions. Quickly we will take them and then we will close. Will electric vehicles have a effect on power quality of grid?
Yes, to some extent, yes, it's expected that there will be an impact on the power quality. And that is where the grid companies are gearing up towards it to see how they could fix it. And to some extent, as we go along, V2G will help in harmonizing some of those. But I think these are all more detailed questions, so maybe I will not get into the details right.
Yeah. Can you share something on SOC methods? This is the another question.
Uh, So it's state of charge. I don't know what the explicit question is, but what I can tell you is that for some things in coming out of BMS. There is a lot of digital technologies being used to collect this data, to analyze the life cycle of the battery, to improve the life cycle of the battery. A lot of things are being done. If that was the question, but it's not very specific. So we'll move on to the next one.
Yeah, can we use trickle charging method for solar-based electric vehicles?
Uh, Pranali, I'm not aware of this, so I wouldn't answer this because I'm not aware of whether it's being used. I have no idea. Uh, Logically, yes, but I'm not sure. I've not seen it.
Is there a possibility to convert an old car in working condition to an EV? Any policies in this area?
Yes, there are companies, again, not taking the names. There are companies who convert old auto rickshaws to electric vehicle, two-wheelers to electric vehicle, cars to electric vehicle. But after 2, 3 years of their business, I think they all realize that it's not a viable business model. Though their IP is on converting, there are kits to convert this. And there is also a challenge that these vehicles, when you convert these, Indian government law reads that you need to homologate these vehicles, which is a very, very lengthy process. So many players don't want to get into it.
Yeah, so the last question and answer, he is providing answers for trickle charging. So you will be happy to note that Daniel Lotis has joined your talk from US. He is our tomorrow's speaker for the webinar. He is giving information that in the United States of America, owners of EV, mine is a Nissan Leaf, can usually charge at home, trickle charging at 110 volt standard. Does the grid in India allow comparable at home charging? No
Uh,
overburdening with bad consequences of neighborhood. Yeah.
Yes, if you have solar installation, like I said, in the charging parks and also at home, it's allowed. But typically, right now, most setups being done is mainly taking from the grid. But there are some installations coming up in charging parks which are trying these. But home charging is typically now with from a grid connection. Not too many installations where you try with solar coming in.
Thank you, sir. Thank you very much for delivering very, very nice and informative session on role of electric vehicles in 21st century and its relevance to in India. And we have covered almost all the questions. I know we are now at 7:21, so we will be closing now our webinar. Thank you very much on behalf of IEEE Bangalore section and on behalf of all the participants. I would like to formally thank you for this excellent session. And I would also like to thank all the participants. Now we will be meeting tomorrow again at 6 p.m. Our next speaker will be Daniel Lotis, who will be talking about sustainable technologies for urban poor. Thank you very much. Ravikiran sir,
Yeah,
you
thank you,
can give
Puneet,
your
for
concluding
this
remarks.
opportunity.
Yeah.
And thanks everybody for listening to me. Thank you.
Thank you, sir. Thank you very much.
Yeah, thank you.